Hi guys, good evening. Yes guys, good evening. Can you hear me? Hello. Can you hear me?
Yes, sir, we can hear you.
Yeah. So thank you. So let us start session. Yes, last class. See about this introduction completed. Yes, introduction to software. Yes, that introduction completed. System software, application software. Next about OS discussed. Front and back end discussed. Low level language discussed. Okay. Yes, next step. Just generation of computers and all this completed. Okay, next about interpreter and compiler also completed. Java depends on both the compiler as well interpreter. So this topic also completed. Okay. So next step. Java is an independent platform. How Java made us independent platform? This topic we should discuss today. The Java features. Yes, now you can understand Java features very clearly. Now you can all basics were discussed. Now you can understand very clearly how Java made us independent platform. Yes, today topic. Yes, Java is an independent platform. Yes, what does it mean? What does it mean? Java is an independent platform. What does it mean? Let's see. Yes. What does it mean? One second, someone is trying to join. Yes, Java is independent platform. Yes, what does it mean? Here platform means OS. Platform means operating system. Platform means operating system. Platform means OS. Java is an independent platform means Java is an independent of operating system. Platform means operating system here. Independent of operating system. Operating system. That means here Java program can run on any ways. Java program can run on any ways. Simple meaning. Java on any ways. Java program can run on any ways. That means yes, Java can run on any ways. Just 1 second. Somebody is trying to join. 1 second. See, Java is independent platform. Means Java program can run. Okay. Yes. 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 Now your question is here how Java made us independent platform. How Java made us independent platform? Is the question. How how Java made us independent of platform? So this is a question. How Java made us independent of platform? How Java made us independent of platform? Yes. To answer this question, yes, about exe file and dot class file. Yes, we must have the knowledge of exe file. Yes, about exe file and the dot class file. Yes, so you must have this knowledge. Yes, if you know about exe file dot class file, then easy to understand this topic here. So how Java made us independent of platform? How Java made us independent of platform? Yes, let us see. So about exe file and dot class file. So first of all about exe file. Yes, first of all about exe file. Exe file. So what is exe file? Yes. What is an exe file? What is an exe file? See, exe file is a binary code file. Exe file is a binary code file, and it is a system understandable language. System understandable language. It's a system understandable language. It's a system understandable language. Exe file. Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. It's a system understandable language. Okay. So what is exactly exe file? Let us see. Some question for you guys. Some question. Exe file prepared. Exe file prepared on Windows OS. Exe file prepared on Windows OS. For example, exe file prepared on Windows OS. Yes, can I run on Linux base? Can I run on Linux base? Yes, anyone, can you answer this question? Exe file prepared on Windows OS, can I run on Linux base? Exe file. Yes, exe file prepared on Windows OS, can I run on Linux base? Anyone, can you answer this? Yes, just of course I will explain very clearly. Just I'm asking your idea. Exe file prepared on Windows OS, can I run on Linux base? Yes. Answer is no. No, we can't. Yes, reason. Yes, exe file is a OS dependent. Reason, exe file is a OS dependent. Exe file is OS dependent. Reason, exe file is OS dependent. Reason, exe file is a OS dependent. Exe file is a OS dependent. Okay. Exe file prepared on Windows OS, can I run on Linux base? Answer is no here. Reason, exe file is a OS dependent. Exe file is a OS dependent. Okay. Now immediately question, why exe file is OS dependent? OS dependent. Why exe file is OS dependent? Yes, immediately question, why exe file is OS dependent? Yes. Let us see about exe file now. Yes. So to answer this question, you should know about exe file. So why exe file is OS dependent? For this answer. Yes, to answer this question, yes, about exe file. We should discuss about exe file. So about exe file. About exe file. See, for example, here, exe file prepared on Windows OS. For example, C program exe file. For example, C program exe file prepared on Windows OS. Then it contains that's what C program. For example, C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains binary code for C program. Yes, I'll show practically binary code for C program plus binary code for C library, binary code for C library, binary code for C library, binary code for C program, plus binary code for C library, plus binary code for OS library. Yes, here it's a Windows OS library. Windows OS library. This is complete exe file. Okay. Yes. If exe file, yes, C program exe file prepared on Windows OS. C program exe file prepared on Windows OS, then it contains binary code for C program, binary code for C library, binary code for Windows OS library. That's it here. Yes. What does it mean? Let us see. Let us say about C program. C program. Yeah, this is some C program. Okay. C program, right? C program. See, in previous class, interpreters and compilers, the difference. Same topic discussed. C program. Test.cpp. Here, this is C program code. And this is a library. It's a library. Predefined library. Predefined library. Yes, C software library. Yes, it's a library. C software library. Okay. See, this library having its own binary code. C library having its own binary code. Like stdio data setter file, con data setter file. These data files having its own code, some binary code. Okay, fine. Now, C drive, DC folder, yes, bin folder, yes, here. What is name of the program for test.cpp? Test.cpp. Test. So here they say test here. Test. Let me delete old files. Delete all the old files. See, test.cpp. See, I'm compiling. So when I compile, what happens here? See this backend. Yes, one file generated just now. 7:34 p.m. 21 and just now created one file. So what is this file? Let us check it. Right click, properties. Yes, this is a .obj, right? Means object file. It's an object file. Object file. So what is this object file? This object file contains what? Yes, binary code for our C program. This is a complete C program binary code. C compiler converts this complete code into binary format. C compiler converts this whole code into binary format and write into test.obj file. So this test.obj, that object file contains binary code for C program. Next, one more thing here. So these libraries also having its own binary code. Yes, apart from this, OS also having library. That library also binary code library, OS library. So by linking all of these things, yes, your C program binary code, yes, C software library binary code, and OS library binary code. By linking all of these things, generates exe file. So binary code for C program, C library, binary code for OS library. By linking all of these things, generates exe file. Yes, C compiler by linking all of these things, generating exe file, generating exe file. Okay. One more example. Let us take another example. Another example. Sorry. Just a minute. Another example. Suppose C program exe file prepared on Linux base. Then it contains what? See binary code for C program, binary code for C library, next binary code for Linux OS library. That's it. Yes, OS library. See, beginning we discussed. Yes, see OS. Instead of OS, there is library. Here there is library. Inside the OS, there is library. Yes, purpose of this library is to communicate with hardware components. So purpose of this library to communicate with hardware. Now what happens here? These programs, C, Java, Hadoop, all the programs first of all linking with OS library. Of linking then communicates with hardware. See, previously we discussed one point. This is every program has to link with OS library before going to run. Every program has to link with OS library before going to run it. Linking then execution. Okay, the OS library linking, right? OS library linking. Okay, see here. Yes, this one. C program exe file prepared on Windows space. Then it contains binary code for C program, binary code for C library. Next, binary code for OS library. So OS library also linking with that exe file. Okay, suppose C program exe file prepared on Linux space. Then links with Linux based library. Yes, let me show on Linux space. Linux base. Linux base. Same thing on Linux base. Yes, let us say same thing on Linux base. Yes, now in Linux base you can see practically. Yes, see Windows base Turbo C. Yes, it's backend compiling and backend creating exe file. All this thing happens in the backend. Okay. Yes. So this exe file. See when you run this. So when you run this, now running here. When you run it here, see that exe file created executed. Exe file created executed. How that exe file created here? Yes, binary for C program. This is object file. Binary code for that C library. Binary code for C library. So this is binary code for this library. Binary code for C program is this is test.obj. Next binary code for OS library. By linking all of this, it generates exe file. That is finally exe file. So Linux login. Linux login. Yeah, this is most important topic. Okay, independent of platform, compulsory interest getting here. So that time you have to explain about exe file also. Okay, yes. So that OS library, Windows OS library, here Linux OS library. Just let me show in Linux also. Linux OS. PWD demo ls mn cd mn changing. Then work in that mn ls. Yes. Remove that star star dot r dot o ls. See, here our topic is about exe file, not about Linux. You guys don't worry about Linux commands. I'm using some Linux commands. Yes, no worry about Linux commands. Leave it. Yes, topic is about exe file. See test.c program. Just I'm opening that file. Gread test.c like a Windows notepad. Gread is like a Windows notepad. It's like a Windows notepad. Test.c. Opening. It's opening here. See this. A is equal to B is equal to C equal to A plus B addition, subtraction, multiplication. Right? So this is simple program. C program. Okay. Now this program, yes, first of all compilation. CC -C test.c compilation. Yes, compiled. After compilation, result is test.o means object file. Yes, here are same like a Windows base. Windows base test.o with that object file created. Like that here Linux also an object file created. So this object file contains binary code for C program. That object file contains binary code for C program. So with this part, this whole part converts in binary format and write into that object file test.o file. Next here library, C library. This also having its own binary code. Yes, stdio data header file included. This is having its own binary code. Okay. Yes. Apart from this, Linux is also having library. That library binary code. By linking all of these, generating exe file series cc -c compiled test.o file created. Now I'm creating exe file cc-o the project exe file. Okay, test.o. Yes, created ls. See, this exe name can be anyone. Project exe file. Okay, it can be anyone. That name can be anyone. Projects. Yes, running that addition, subtraction, multiplication. multiplication, addition, subtraction, multiplication. Here this name can be anyone, no issue. Okay, suppose Durga, the ex name. Yes, created by name of Durga, created. Okay, dot slash. I'm running that. Yes, executed. Addition, subtraction, multiplication. Here this is here it's exe file. So exe file. How that exe file creating? Same process, same process. Exe file creation. See, here this option. CC means C language compiler. CC means C language compiler. Hyphen means yes, linking object files and generating project exe file. Now C compiler taking object file for C program, bind record for C program, bind record for C library, stdiv data set file included. stdiv data set file. Next, bind record for voice library. By linking all of these generates that project exe file. Yes. See project exe file. Yes, we can check it. The exe file. Gedit. I'm opening the exe file. Gedit project exe file. Gedit. I'm opening the exe file. Yes, exactly what does it contain? Let's see. Opening the exe file. See this exe file, binary format. Binary format. Yes, system understandable language is exe file. That's exe file format. Exe file format. Next in Linux we have from commands to check the type of exe. Here there's a file command. Linux there's a file command. Linux there's a file command to check the type of exe file. Support test.c file I'm checking. Here this file command checking type of that program, the type of a test.c. Test.c, C source code ASCII text. Test.c, C source ASCII text. C source ASCII text, right? ASCII text. Okay, same thing. I'm checking the project exe file. Projects. File command checking type of that file here. Type of exe. See that? Executable. So project is the executable file. Okay, right? Now this here, see ld-linux x86 64.s4, right? Here this is Linux OS library. Linux OS library. Yes, it's actually embedded C concept. Embedded C concept. So Linux OS library. See, Linux OS library also included in this project exe file. Here this file command saying about project contents here. Exe about exe file. This file command showing about exe file. Yes, project. It's the executable file. Executable file. Okay. Yeah, this is Linux OS library. .o. .so is an extension for the Linux OS library. .so. OS library extension. This is. Now it's ld-linux means the Linux OS library. This library linked to project exe file. That's here. So this library linked to project exe file. So that exe file. Okay. C program exe file prepared on Linux base. Then it contains yes bind record for C program, bind record for C library, next bind record for OS library. By linking all of this in generating exe file. Suppose let us take one more example. Let us take one more example. One more example. Sorry, what's happening? One more example. Yes. One more another example. C program exe file prepared. C++ program. Let us take C++. C++ program exe file prepared on Windows OS. Windows OS. Windows OS. Then it contains binary code for C++ program. Binary code for C++ library. Binary code for Windows OS library. Windows OS library. Now tell me guys, what is commonly happening here? All three cases. Here first case, next case, next case. What is happening all the cases? Yes, here binary codes. Yes, binary code for OS library. Here OS library, here also OS library, here OS library. In all the cases, yes, OS library linking, right? So all the cases. Okay, so what is happening? exe file, always linking with OS library, always linking with OS library. That's it here. So all the cases, yes. See, C program on Windows OS, C program on Linux OS, C++ on Windows OS. All the cases, yes, exe file always linking with OS library. Okay, so linking with OS library. Okay, yes. Suppose, for example, here, test.exe file, prepared exe file, prepared on Windows OS, Windows OS, Windows OS, Windows OS, sorry, Windows OS. For example, test.exe file prepared on Windows OS, then it links, links with Windows OS Win library, links with Win library. That's it here. Okay, so now test.exe file, that exe file, test.exe file with Win library, library running on different operating systems, of which working on different operations. Okay, yes, important points. Try to focus on the class. Try to listen clearly. Very interesting thing here. S.exe file with Win library running at different operating systems or platforms. Different operations or platforms. Let us see different platforms. First, let us take Windows platform. Yes, your computer. Yes, computer. Yes, computer. Here is the hardware, right? Hardware. There is a hardware. Okay. So on top of hardware, OS running. Operating system. Right? Yes, on top of operating system, all programs running. On top of OS, all programs like C program, C++, Java. On top of it, all are running. Yes, previously we discussed OS is a platform. On top of it, all are running. Now C program, test.exe file, right? Now, yes, Windows OS. Let us take Windows OS. Yes, Windows OS. Yes, Windows OS with Win library. Windows OS with Win library. So Windows OS with Win library. Just have it. Okay. See. So when you try to execute test.exe file, yes, this test.exe file try to call to Win library. Yes, reason here. See, test.exe file prepared on Windows OS, then it links with Windows library, links with Win library. Test.exe file with Win library means all are linked. Instead of exe file, Windows library is there. Instead of already linked, already inserted in the exe file. So Windows library is a part of exe file. Okay, so when you try to run this test.exe file, it will try to call Windows OS library. Since test.exe file, linked with OS library, Windows OS library, simply it will try to call to Windows OS library. Yes, available. Using that library communicates with hardware, so successfully executing that program, executing successfully. Now let us take another platform. One more platform. Let us take another platform. Yes, another platform. Another platform. Another platform. Okay. Yes. Next Linux base. Let us take Linux base. Linux base with Linux library. Yes, how it's working. Linux base with Linux library. How it's working. Just a minute. Just a minute. Yeah, I'm taking some more. Just a minute. Yes, no Linux base with Linux library. Right? Yes, now same exe file if you try to execute a Linux base. Yes, test.exe file if you're running a Linux base, not test.exe file if you try to call Windows base library because already linked. That link is fixed. That link is fixed. Okay, already linked with Windows base library test.exe file prepared Windows base. Then linked with Windows base library. Links with Windows first, already linked. That is fixed. That link is fixed. That link is fixed called as statical linking. Statical linking. Yes, we'll discuss. Wait. Okay. Yes, since test.exe file already linked with Windows base library, it will try to call Windows base library, but here is not available. That library is not matching. Simply it fails. It fails. It fails. Let us take one more platform, macOS. Let us take macOS. macOS. Suppose same exe file. If you're running on macOS here with Mac library, macOS with Mac library, macOS with yes Mac library. Now what happens? Here also this test.exe will try to call Windows base library because that link is fixed. Never changes. Never changes. But not all fails. That's the reason exe file is base dependent. Exe file is base dependent. That link is fixed. It won't change. That link is fixed. So that exe file linked with Windows base library, since it contains Windows base library, it will run with only Windows base. It cannot run on other operating systems. It cannot run on other operating systems. That's the reason exe file is OS dependent. Okay. So why exe file is OS dependent? Why exe file is OS dependent? For this answer, yes, exe file. Exe file contains OS library. Yes, contains OS library. Exe file. Since exe file contains OS library, it's a OS dependent. OS dependent. Okay, OS dependent. Okay. Yes, here what happens here? Exe file. See exe file statically linking with statically linking with OS library. OS library. Yes, it is a OS dependent. Yes, it is a yes. Yes, it is an OS dependent. It's an OS dependent. OS dependent. So what is statical linking? I will explain. Just wait. I'll repeat topic once again. Statical linking. Static means fixed. Static and dynamic. Static means fixed. Dynamic means changes at any time changing. Okay. Statical linking. Yes, about statical linking we'll discuss. Wait. So about exe file. Since exe file contains OS library. Yes, since exe file contains OS library. Yes, it's a OS dependent. Why exe file is OS dependent? Reason it contains OS library. Exe file contains OS library. Yes, about exe file. So exe file is a OS dependent. Reason it contains OS library. Now let us see Java. Let us start Java. Yes, let us start about Java dot class file. About dot class file. About Java dot class file. About Java dot class file. Let us see. Java program dot class file. Java program dot class file. prepared on Windows OS, then it contains what? Yes, binary code for, no, not binary code. Java, it's a bytecode. Everything is bytecode. Yes, bytecode for Java program. Bytecode for Java program. So bytecode for Java program. Next, bytecode for Java, like a C library here, Java library, right? Next, binary code for Windows OS library. No, don't have this. No. Okay. So bytecode for Java program, bytecode for Java library. See, Java library also developed in Java. Java library also developed in Java. Means dot class was a purely Java program. So dot class file. So dot class file. Dot class file is a pure Java program. Is a pure Java program. Pure Java program. A Java program. Yes, in bytecode format. So dot class file is a pure Java program in bytecode format. Okay. So dot class file. See, dot class file don't have OS library. Okay, don't have OS library. Yes, it is free from OS library. Free from OS library. That's it. Okay, yes. Now let us take some example. Tested dot class. For example, tested dot class file. Yes, tested dot class are prepared on anyways. Yes, it don't have anyways. It don't have any ways library. Don't have any ways library. Let no ways library. Dot class file is free from ways library. Don't have any ways library. Pure Java code. Okay. Yes. Now tested dot class file is working on different platforms. How it's working on different platforms. Let's see. Tested dot class file. Tested dot class file working on different platforms. Tested dot class file working on different platforms. Yes, how it's working on different platforms. Tested dot class file working on different platforms. How it's working. Yes. First, let us take Windows platform. Like previous example, same Windows platform. Let us take Windows platform. See Windows platform. Yes, on this tested dot class file running. Tested dot class file. Yes. Suppose if I am running tested dot class file directly, will it run or not? No. It won't run. This tested dot class file won't run. Reason. See, every program has to link with OS library. It has to link, otherwise cannot communicate with hardware. C program, C++, Java, Hadoop, all programs have to link with OS library. Yes, why linking with OS library? To communicate with hardware components. It has to link with OS library. It's a compulsory. It has to link with OS library. Okay. Yes, suppose if it is exe file. At the time of creation of exe file itself, that linking, right? Linking with OS library. All are linked. At the time of creation of exe file itself, linking. But in Java, it's not linked. But it has to link. Every program has to link with OS library. Otherwise, cannot run. Now, this .class file also has to link with OS library. Yes, it's not linked. It's not free from OS library. It's not linked, but it has to link. We will link it here. For linking purpose between .class file, Windows OS, one more layer will come to picture. Yes, what is this layer? Anyone can guess it? Between .class file, Windows OS, one more layer comes to picture. What is that layer? Anyone can guess it? Between .class file, Windows OS, one more layer come to picture. One more layer. So what is that layer? Yes, anyone idea? Anyone idea about it? Yes. That layer is a JVM layer. Java virtual machine. Java virtual machine come to the picture here. Java virtual machine. Java virtual machine. Now what happens in JVM? Simply here JVM taking test.class file and links with Windows OS library. So JVM takes care of that linking. So once linked with Windows OS library, then executes generating output. Now let us take another platform, Linux platform. Let us take Linux platform. See Linux base with Linux library. Submit platform. Yes, on Linux base also there is JVM. Linux JVM taking your .class file and links with the Linux base library. So once linked here, communicates with the hardware, then successfully completing. Yes, let us take one more platform, Mac OS. Yes, Mac OS with Mac library, Mac OS with Mac library. On Mac OS of the JVM, Mac JVM taking .class for links with Mac library. Now what is happening here? Every time of changing OS, that link is changing. Okay, every time of changing. See, for every time of changing OS. Yes, link is changing, right? Link is changing. Every time of changing OS, link is changing. Okay, right? Yes, link is changing. Yes, it is called as dynamical linking. It is called as dynamical linking. Dynamically linking. It's called as dynamically linking. Here. Okay, since here .class file linking with OS library at runtime. Okay, see .class file placed on Windows OS. When you're running on Windows OS, links with Windows OS library. Same .class file if you're running on Linux base, links with Linux base library. Same .class file if you're running on Mac OS, linking with Mac library. Right, okay. So this is called dynamic linking. So every time of changing OS, that link is changing. Okay, but in case of exe file, what's happened here? Exe file, that link is fixed. Yes, test.exe file with Win library. Yes, that link is fixed. That link will not change. So that is called linking. Link fixed. If link is fixed, it's a statical linking. Okay. Yes, exe file, statical linking with OS library. That link never changes. Static means fixed. That link is fixed. Link never changes. But when come to Java.class file, see, every time of changing OS, that link changes. Yes, .class file running on Windows OS links to Windows OS library. Same .class file if it is running on Linux OS links to Linux OS library. Same .class file if it is running on Mac OS linking to Mac library. So for every time of changing OS link changes. Every time of changing OS link will be changing. Yes, it is called as dynamic linking. Okay. Yes. So here since Java .class file dynamically since Java.class file dynamically linking since Java.class file is dynamically linking with OS library. Yes, it is independent platform. Independent of platform. Yes, independent of platform. That's clear. So every time of changing ways, that's link is changing. That's the reason called as independent platform. Now Java made us independent platform for this JVM. Okay, since Java.class for dynamical linking with OS library, by the JVM. Yes, it is an independent platform. So JVM makes the Java program file as independent platform. So every time of changing ways, that link changes. I hope you understand, right? So statical linking means that is ways dependent. Dynamical linking independent of ways. Okay, fine. Now here some doubt here. I'm saying that Windows JVM linking dot class to Windows OS library. Linux JVM linking dot class to Linux OS library. Yes, Mac OS taking dot class for links to Mac OS library. Right? So JVM takes care of that linking. So that's the reason called as dynamic linking. Okay. Yes. Now, so here, so Windows JVM linking with Windows OS library. Then is it JVM? Is it part of OS? Yes. See JVM running on Windows OS. Is it part of OS? No. Yes. JVM is not a part of OS. It's a part of JDK. JVM from the JDK here. Okay. JVM is not a part of OS. Yes, it is from JDK. It is from JDK software. 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 JDK software. Okay. See, once yes, then how can you get JVM? You should install JDK software. Okay. How can you get JVM? See, JVM is not a part of OS. It is from JDK software. Then how can you get JVM? Yes, to get JVM, yes, we should install JDK software. We should install JDK software. So once JDK software installed, you can get the JVM. Okay, fine. Next, one more interesting point here. See, Java program dot class file is independent of platform. Dot class file is independent of platform, but JVM is always dependent. JVM is always dependent. Okay, see, Java dot class file. Yes, is an independent of platform. Independent of platform. Okay, independent. Yes, Java dot class file is an independent of platform. Independent of platform. But JVM is a platform dependent. Means where is dependent? Platform dependent. Where is, yes, JVM is a platform dependent here. Why? Yes. See, Java, interesting thing is, yes, our Java program file is independent of platform, but actual JVM is a platform dependent. Where is dependent? Reason, yes, JVM is developed in C++. Yes, if developed in C++, what is that? It's exe file, right? In C++, finally getting exe file. It's exe file. So that means JVM is a yes, C++ exe file. Exe file. That's the reason it's a OS dependent. Yes, if it is exe file, definitely OS dependent. That's it. Okay. Yes. Now here, see guys. Suppose I want JDK for Windows OS, right? The JDK must have Windows JVM. Okay. Yes. JDK must have Windows JVM. Okay. Suppose JDK Linux OS means that JDK must have Linux JVM. So every time of changing with that JVM changes. JVM is OS dependent. Okay. Yes. Windows to install JDK and Windows OS, that JDK must have Windows JVM. Suppose if it is a Linux OS, that JDK must have Linux JVM. Suppose if Mac OS, that JDK must have Mac JVM. So means, so JDK JVM changes. Since JVM changing, JDK also changes. Since JVM is OS dependent, JDK also OS dependent. Okay, see, one more interesting point here. Yes, interesting point. Since JVM is OS dependent, JVM is OS dependent here. JDK also, yes, OS dependent. OS dependent. That means same JDK you cannot install on different hardware. Same JDK cannot be installed. Same JDK cannot be here. Suppose C drive. Here this is JDK. Windows JDK available. JDK. Windows JDK, right? It's a Windows JDK. JDK you can't install in other operations. This JDK we can't install in other operations. Okay. Yes. 1 second. Let me show that. Let us go to that Oracle site. JDK. Download JDK 1.8. See Oracle Corporation. Oracle Corporation site. See this. These are all JDKs. See this different JDKs available. See this is JDK for Linux OS. Like this is JDK for Mac OS. JDK for Solaris. JDK for Windows OS. Depends on ways that JDK changing. Okay. For Windows OS, we should download last one. Last one. See, you guys, no, don't worry. You need not to download. Yes, I'll provide you. Okay. I'll provide you. It's there in drive. I'll give the drive access. Yes, at drive level, the JDK is available. Yes, almost I think, except 1 or 2 students, access given to everyone. See, this is core Java. So this is JDK. Yes, access given to this drive. This JDK is available, Eclipse available, okay, and all that material. Yes, at drive level access given. Access given to many of the students. Okay. Yes. Now, how to go to Google Drive? Yes, your Google Drive. How to download these things? How to install? That is tomorrow topic. Tomorrow we are going for Java installation. Yes, with this topic, today topic, all the introduction, Java introduction completed. Next, you have to install JDK software. So tomorrow topic will discuss about JDK software. Yes, how to install Java. Tomorrow topic is about Java installation and Eclipse setup. Tomorrow topic, Java installation. So and Eclipse setup. Next, writing first application. Yes, tomorrow entering into Java coding, Java programming, Java installation, Eclipse installation. Yes, after finishing, how to write first application we'll discuss. Okay, that's fine. Yes, today topic. Finally, conclusion. See exe file dot class file. What's the difference between exe file dot class file? Exe file dot class file. See exe file is a binary code file, right? Simple differences. Exe file is a binary code file. Dot class is a byte code file. So this is important difference. Okay. Yes. Next. See exe file contains OS library. This is one more important difference. It contains program code software next OS library. Exe file contains OS library. See dot class file don't have OS library. Don't have OS library. Okay. Right? Next one more important this difference. See exe file statically linking with OS library. That statically is fixed. That link never changes. Fixed. Next here OS library dynamically linking with with exe file. Okay, dot class file. So OS library dynamically linking. So their main differences. See exe file binary code file, dot class byte code file. Next exe file contains OS library. Dot class file don't have any OS library. Next exe file statically linking. Yes. Next dot class file is dynamically linking. That's the difference. Yeah, that's all about independent platform. Okay, independent platform. So with that, all that features completed. Okay, yes, all that introduction completed. Next, installing Java. So this topic tomorrow we continue. Tomorrow going for Java installation. Okay, yes, if anyone pending with the drive access, yes, today I'll give the drive access. Today night I'll give the drive access. Yes, I'll talk to online team. As per their information, I'll give the drive access. Okay. Yes, tomorrow going for installation. Yes, by tomorrow class. Yes, going for installation. Okay. Yes. Still any doubts? Yes, guys, any doubts? Any doubts? Yes, if no doubts, let us wind up session for today. Let us wind up. Okay, let us wind up session for today. So thank you guys. Yes, see you tomorrow. See you tomorrow.